Hello. So for Math 119, I want to talk about Chapter 3. I already posted a copy of all the document I want to talk to you guys today on Canvas. So now I want to go briefly over some of the stuff here. So Chapter 3. There are two definitions that you want to use this one. I think one or two questions on your homework is asking about descriptive versus inferential statistics. So you could actually read this yourself. These are all just the terms that we are using. Then the measure of the center. These are all basic concept of measure of the center. The value at the center or middle of the data set. So arithmetic mean. Mean is measure of the center obtained by adding the value and dividing total by the number of values. What most people call it the average. In the statistic, we don't call it average, we call it the mean. Like I have $4, somebody else has $2. So if you want to take an average of our money, 4 plus 2 is 6, divided by 2 is $3. So how do we calculate that? We find some of the data set, and then variable usually used to represent the individual data set, and then I want to see the difference of sample of population. Normally for population, we use the word all. I think we discussed that in chapter 2. And sample is when you just take random numbers from the entire population. This is a formula that we use for mean. This is sample mean, and this is mean of sample. This is mean of population. Both are the same thing. So when you work on the problem is either you take a sample or you use entire population. Either one is the same formula. It's just the different letters here, okay? So if there's any indication in the problem that you're using populations or you're using the word all, then that's the one to write. And if it's a sample, you randomly take some numbers, is that. And then we talk about the advantage and disadvantage of the mean. The only problem with the mean, one of the problems with the mean is, let's say you want to buy some homes and price of the homes are vary. So in one neighborhood, they all are kind of pretty close, and there is a house which is extremely expensive. They call it outlier. That impact when you normally you don't take a mean because that would impact your mean. So this advantage is sensitive to the data value. Median is where we use, especially in real estate, they try to use the median because median would eliminate or ignore impact of outliers. So it's not affected by extreme value, which is the outlier. To understand how to find the median, if the number of values is odd, the median is in the middle. 2, if the number is even, the median is 5 by average. So to understand the definition, I think these are the good examples. Look. So the number, if the numbers are even, then to find the one exactly in the middle, you got to take the average of these two. But if the number is odd, then the number in the middle we can easily find. Okay. So let's look at a very simple example. Let's say you have these numbers: 2, 3, 5. What number is exactly in the middle? This. The median is 3. How many numbers do you have? Odd. 1, 2, 3. So let's look at this. 5, 7, 13, 20. There are 4 numbers here, right? 1, 2, 3, 4. What number is exactly in the middle? Average of these two. 7 plus 13 divided by 2 is 10. Okay, so if the number is even, there are four numbers. You take the averages to find the standard or the middle. If it's odd, you can find the number exactly in the middle. You know, this is an example I want to show you why we use the median, especially in real estate, than mean, okay? So we randomly went to one neighborhood and we asked the real estate agent, what's the price of the home sold in 1 year? And in one particular area, she came up with these numbers. One house, 380,000, 400,000, 410, 300. And there is one which is really, really large number. Look, 850,000, which we call it an outlier because it's way away from the other numbers. When I take the average is 438,000. Okay. So in that case, if I go ahead and take the median, if you want to take a median, then you have to put the number in order from the lowest to the highest or vice versa. So in that case, 1, 2, 3, 4, I have 6 numbers, and you take the average of these two middle number, which is 380 plus 400,000 divided by 2, and that gives you 390. See, these numbers, you kind of ignore this large outlier. So outlier really does not impact the median that much as it does for mean. That's why most times when you want to come up with the value, especially as I said for in the real estate, to find the average price of the home sold in the neighborhood, you better use the median rather than mean. So mean is very sensitive to the outlier. Talking about the critical thinking. Measure of the center. Now there are two types of mean. One is from frequency distributions. Assume that all the samples value in each class are equal to the class midpoints. Property of standard deviations. Standard deviation, what it does, measure the variation among the data values. Value close together have a small standard deviation, but value with much more variation have a larger standard deviations. So here briefly tell you how to calculate the mean, median, mode, and mid-range. Mid-range is not commonly used, but you still need to understand it. See, mid-range is the average of, you take the highest value and the lowest value and take an average of that. The most of this definition, when you work on the example, you understand it better. Like this is a good example, okay? We have all these numbers. So what we do is we write the number in order. In this example, number has already written in order from the lowest to the highest. If not, it's better to write it. Why? Because it helps us for the median. Mean is you just add all these numbers and divide by how many numbers do we have here? 10. So divide by 10, that's your mean. And median is what? There are 10 even numbers. So the number exactly in the middle is right here, because I have to take the average of these two. Now, what is mode? Which number is repeated more often, more frequently here? I see that 7.7 is repeated twice, but none of the other number has been repeated. So mode is 7.7. Okay, so let's look at this example here. I have these numbers 2, 2, 3, 5, 6, 6, 6, 12. Look at these numbers. What is the mode here? Mode is this number is repeated 3 times and this number is repeated 2 times. Okay, so we just say mode is 3. I'm sorry, 6. Which number is repeated more often or more frequently? Okay, let's look at another example. I have 5, 5, 8, 9, I don't know, 10, 10, 20, 30. 5 is repeated 2 times, 10 is repeated 2 times. So there are 2 modes here. Modes are 5 and 10, both of them. Okay, and look at another example, 7, 11, 80, 95. There is no mode here. You cannot find any number that is repeated more than once. So there is no mode here. Okay, all right. So range is minimum. You find the minimum number and the maximum number. Since you wrote everything in order, you take the minimum number and subtract from the maximum number. So it would be 10 minus 4. This is the range. What is mid-range? Mid-range is average of these two. Means instead of subtracting, you add together, divide by 2. This is just a definition. As I said, mid-range is rarely used, but we still need to understand it. So we have mean, median, mode, range, and mid-range. And then standard deviations. And how do we calculate the standard deviations? There are 2 or 3 types of formula for standard deviations. One of them is this. Okay? So what we do is we list all the x's. All right? We list all the x's, and then to use the formula, you have sum of x2. So you need to create a new column, which is x2. Means you take each of these numbers and raise it to power of 2. And then you find the sum. You put it here. That would give you the standard deviations, 1.84. There are 2 types of standard deviation. One is when you have all the x's listed like that. The other one is on page 20, when you have the frequency. See, this is like a frequency table, all right? And the frequency table, for us to find the mean, we have to use this formula. This formula is designed for frequency table. So what I need these 2 columns are given. They give you the frequency and they give you the classifications. What is x? X is midpoint between these 2 or average. What number is between 40 and 44? 42. What number is between 45 and 49? 47. How do you calculate? Just take the average. Add these 2, like 45 plus 49 divided by 2. 40 plus 44 divided by 2. That gives you the x value. F times x means take these numbers and multiply by that. Like what is f times x for the first one? 2 times 42 is 84. fx2. To find fx2, you could either multiply these 2, okay? Or you could create another column here, which is x2, and then multiply. But I think it's easier if you just take these 2, multiply. X times fx is fx2. Then you find sum of each, and then you plug into these equations. That gives you standard deviation. So again, there are 2 types of standard deviation. One is for frequency table, okay? And the other formula is for when you have list of the numbers. So this is a formula when you are using the mean also. The mean is different. Mean of frequency table is different with mean of x. This is when you have a frequency table. Sum of fx divided by sum of f. And I show you an example here, look. So this column and this column is given. We give you low temperature, upper or lower, and then frequency. You need to find these two. X, again, X is the midpoint, is a number exactly in the middle, fx. To calculate the mean is sum of fx, means you need to create a new column, which is fx. You add them together, you put it here. And what is sum of f? This is the important one. Sum of f is you add all the frequency. And then you put it here. That gives you mean of frequency table. We also have mean when the data value is assigned a different weight. Then you compute the weighted mean. Wx divided by sum of W. And for that, I'll show you an example here. Any of these, you could always pause it and make a copy or just write your explanations. All right, so in this case, this student is taking 5 classes, okay? He's taking the math, which is 4 credit, and English is 3 credit, chemistry 4, and so on, right? He got a B on math. So we understand B is 3, A is 4, C is 2, and so on, okay? So what we need to do is formula says sum of the quality point. Quality point means if you get a B in math and it has 4 credits, you take this 4 and multiply by your 3. In English, which is 3 credit, we got a C. C value of C is 2 points. So 2 times 3 is 6, and then divide by how many credits you have. You add all this to see the total credit. This is how you could calculate your GPA. In fact, it is a good thing for you to look at one of the semester and take all your classes and follow this rule to see if your GPA match what they coded in your transcript. That's the good practice to do. So that's how they calculate the practice. I mean, that's how to calculate the GPA for each semester or for an entire year. This is another example. This is student number 2 take 4 classes, and this is his or her grades. How would you calculate the GPA? Same way. Now, to understand the standard deviations, I put 3 examples here, okay? See, here, we study in 3 different banks. First, in one bank, we measure how long does it take to serve 3 customers. The first customer who walked into the bank, it took 6 minutes to be served. The second one also 6 minutes, and the third one was 6 minutes, okay? So what we did, on the x-axis, we put all this class here. This is a histogram for this one. Since they all have 6 minutes, they all spend 6 minutes, see, this is your line. They all have the same mean. Now, we want to calculate later on to show you that standard deviations, what it does is show variation from the mean. If all these numbers are close to the mean or not. Mean is 6, and they all spend 6 minutes, means there is no variation from the mean. So this particular one, standard deviation has to be 0. However, on the second bank, first of all, how do I take the mean? Mean is you always add all 3 numbers, divide by 3, right? When you do that, the mean is 6. Now, Mean is 6, but the first customer spent 4 minutes to be served. Second one, 7 minutes, and third one, 7 minutes. You see, there is a variation from the mean. We do the calculation and find the standard deviation for this, which is, in this case, is not 0, it's like 1.73. I'll show you the calculation later on. The third bank, which is multiple lines, again, the first customer wait 1 minute, then 3 minutes, and 14 minutes. You see that if you want to calculate the mean, you add all these 3, which is what, 18 divided by 3, 6. But the first customer wait only 1 minute, then 3 minutes, and then jump to 14. You see there is a large variation from the mean. So standard deviation calculate variation from the mean. So in that case, what I did was then I used the formula and calculate standard deviation for each. The first bank, 0, no variation. They all waited 6 minutes and the mean was 6 minutes. Second one, there was a variation, 1.73. The third one was the larger one, the 7. So that shows you how to calculate the standard deviation. What does the standard deviation do is show you variation from the mean. You know, this is also the same thing that we did the calculations, you know, using the different formulas. See, there are 2 formulas. One is to find the standard deviation. One is this one. These are not for frequency table, just the normal numbers. There are 2 ways to do it. Either one is correct. Sometimes this is a shortcut, is easier. But if you want to use this one, this formula, X bar means you have to find the sample mean, okay? See, for instance, we want to calculate a standard deviation for the third bank. Remember, third bank was 1, 3, and 14. Mean of the third bank was 6. So the column that you have here in this, it asks you to find X minus sample mean. Means 1 minus 6 is -5, 3 minus 6 is -3, and so on, right? So you take all these numbers and you put in this formula, and that gives you the standard deviations. Then on this example, I show you how to calculate using this formula and also this formula. You know, you have a choice of which one to use. Range is, you know, the lowest number minus the highest number. And sometimes, to make it very easy, it's just rough calculation to find the standard deviation is just take the range and divide by 4. Range is what? The lowest number minus the highest number, right? You do that, divide by 4. That just gives you a rough numbers about the standard deviations. And then we have coefficient of variations, which is a standard deviation divided by sample mean multiplied by 100. This is for the sample, this is for population. And there is an example here to show you how to do it. Okay? All right, so this is the first part of chapter 3, and the next video, then I'll continue with the second part.